Okay, hello students. So today in this lecture we are now continuing the topics that we have done in the previous lecture. In the previous lecture we did your property number 1, that is we did some of the formulas for various functions of Laplace transform, and after that we did property number 1, that is first shifting property, in which we have your function fx multiplied with eax. Now we come to the property number 2, that is called as your differentiation of Laplace transform. So this is the property 2. So in this property, what we have here, let f is a function that is piecewise continuous and of exponential order c for all x greater than or equals to 0, so that Laplace of fx is equals to ft. Say, then according to this property number 2, we see that if you are getting the Laplace of x dot fx, that is when fx is multiplied with x. Remember that in property number 1, fx we were saying that fx multiplied by eax. Now here fx is multiplied by x, and this is minus of f dash p, that is minus first derivative of fp, where fp is the Laplace of fx. So this is the property number 2 that deals with the multiplication of x with fx, the Laplace of the form x dot fx. In general, because this is the most commonly used form, so we were writing this form. However, the common in general, this formula is x raised to power n fx minus 1 raised to power n. This is f nth derivative p, that is minus 1 raised to power n nth derivative of fp. This is, so here is the formula for our property 2 that we are going to use whenever we will get in our questions form like this whose Laplace we have to find. So let us start with the examples and see how this property number 2 works. Find the Laplace transform of gx is equals to x cos 3x. So solution, we have to find the Laplace of gx. So since this is first example, so I will do it in full detail. So Laplace of this is x cos 3x, and you can see here this is of the form x dot fx, that is the form we have in property number 2, where your fx is equals to cos 3x. So according to this property, whenever we have this form, then this Laplace is equals to minus f dash p. That is, first we have to find fp. What is fp? Fp is the Laplace of fx. So first we need to find the derivative of Laplace of fx, that is fp, then take its derivative with a negative sign. So here you have fx as cos 3x. So Laplace of fx, that is what we have to find first, is cos Laplace of cos 3x, and that is p upon p square plus 9, and this is your fp. So if the Laplace of cos 3x or fx is this one, so by property 2, Laplace of x dot fx, that is in this case it is x dot cos 3x, it is minus of f dash p, that is minus dy dp of fp, and fp is given here, we have found it earlier. So this is minus dy dp, fp is p upon p square plus 9. So on differentiation, this gives you p square minus 9. If you differentiate it, you will get p square plus 9 whole square. So this is what the Laplace of x dot cos 3x. This is. So just what we have to do, find the Laplace of fx. You got ft and then take its derivative with negative sign. So here is your the Laplace of this x dot cos 3x. Now I am coming to example 2. Find Laplace of x square dot p 3x. So I am now doing this question straightforward. So here you can see again Laplace of gx. Just for your convenience, I am just writing it in the form so that you can understand. It is x raised to power n dot fx form, where n is 2 and fx is e raised to power 3x. So this is the form of property 2, xn dot fx multiplied by x raised to power n. So we need to find the Laplace of fx. So since Laplace of e3x, I am writing directly now, is 1 upon p minus 3, since Laplace of e raised to power 3x is 1 upon p minus 3, therefore the Laplace of x square dot e raised to power 3x by second shifting property, I have this thing, minus 1 raised to power n, and the derivative of fp upon dpn. So here n is 2 here, x square. So this will be minus 1 whole square, second derivative, double derivative of fp. This is 1 upon p minus 3. So this is your del square or d square, derivative of your 1 upon p minus 3, and this comes out to be your 2 upon p minus 3 raised to power 3. Yes. So this is how we can solve this type of question. Now here again you can see first shifting property, we did also the same thing. Find the Laplace of fx, and when you have to find the Laplace of ex dot fx, just change that p into p minus e. Similarly here, find the Laplace of fx, and when you find xn, Laplace of x raised to power n dot fx, just apply the formula of property 2, minus 1 raised to power n, and its nth derivative. So here it was the second derivative. So this is how we usually do these type of questions. Example 3. Now let us see one more question. Find the Laplace transform of gx is equals to x e raised to power minus 3x sine 2x. So we have to find the Laplace of gx, where gx is x e raised to power minus 3x sine 2x. So clearly, looking at the given function, you can see there are more than one property that is going to be used in this question. Here you have the multiplication of fx, that is fx here is your sine 2x. It is going to be multiplied with e raised to power minus 3x, and also the function is again also multiplied with x. So there is a combination of two properties that is going to be used here, one by one. So let me write it in the form e raised to power minus 3x x sine minus 2x. So we will start from extreme right, that is I am writing e raised to minus 3x because it is always better to use the first shifting property, that is ex dot fx, in the last. That makes the things easy. Otherwise it is not going to affect your result, but it is always better to use the first shifting property in the end or in the last. So I will be using this property x dot fx first. Okay. So how we start this question? We will start from extreme right. So since Laplace of sine 2x is 2 upon p square plus 4, therefore Laplace of x dot sine 2x, this is how usually we do the question. Earlier I was writing fx and something like those. So here I am just writing it directly. So x dot fx is minus dy dp of the Laplace of sine 2x, that is this one, 2 upon p square plus 4 minus times its derivative, and this comes out to be 4p upon p square plus 4 ka whole square. So this derivatives comes out to be 4p upon p square plus 4 ka whole square, and hence the Laplace of e raised to power minus 3x x dot sine 2x is simply whatever you have got the Laplace of this function, that is here you change p by p plus 3, because here a is minus 3. So you replace p by p plus 3, that is p plus 3 ka whole square plus 4 ka whole square. This is the result of this question, in which we have multiple use of more than one property in a single question. So we will be doing these type of questions, or these type of questions are usually asked in the paper, and we will be doing much more these more questions more like this one in our other properties. Since up to this point we have done only two properties, so we are just using here a question where we have the use of these two properties. So this was your example number 3 related to your property number 2, differentiation of Laplace transform. Now I am coming to your property 3, and that is what we call as your, yes, here it is, integration of Laplace transformation. Integration of Laplace transform. So in property, let me first write this, the property, but the property is, let fx be a piecewise continuous and of exponential order c for all x greater than or equals to 0, so that Laplace of fx is equals to fp for p greater than c, no doubt. Also let Laplace of fx upon x is equals to p to infinity, and also okay, let me just hold on. Yes, and here one more condition is there that I just forget, and let limit x tending to 0 positive, as x is greater than or equals to 0, fx upon x exist, and see it exists. Then according to property 3, that is the integration of Laplace transform, then your Laplace of fx upon x is equals to p to infinity fp dp. This is your property number 3, in which there is division of x by fx, and here simply what you have to do, you have to just find the Laplace of fx, that is fp. Once you got this, you just need to take the integral from p to infinity of that fp. So you can now remember these property 1, property 2, property 3 like this way, that in property 1 you have a multiplication of function. Remember that you have in property 1 you have Laplace eax dot fx, and that is your fp minus a. So again here you just need to find the Laplace of fx and change that fp from p to p minus a. So it is, we can remember this, in which there is multiplication of fx by ex. In property 2 we have the multiplication of fx by x, simply because most of the time it is x dot fx, and also we can write it as x raised to power n. So it is minus of f dash p. So the most common form that is used. And now in property 3, property 2, it is the multiplication of x with fx. We try to remember in this way. And in property 3, we have division of fx by x. So these are the way that we can remember. And here we take integral p to infinity f in property 3. So let us see how we solve the questions of this form. So this form is very important one. Find Laplace transform of gx is equals to 1 minus cos 2x upon x. So I need to find the Laplace of gx. Here gx is 1 minus cos 2x upon x. Clearly you can see this is of the form fx upon x. Here this fx is 1 minus cos 2x. So to find the Laplace of this one, because this is going to be by formula p to infinity fp dp. This is what the formula of property number 3 is, and where fp is your Laplace of fx. This is, and fx is your here. So what I need to do again, we have to find the Laplace of fx. So let us find the Laplace of fx. Say this is 1. Laplace of 1 minus cos 2x, that is this one. Yeah, this comes out to be 1 upon p minus p upon p square plus 4. Okay. Now after this one, you got your here fp. This is your fp that you got. Now property 2 says once you get fp, so the Laplace of fx upon x that is being asked in this question, that is, so Laplace of fx upon x, that is Laplace of 1 minus cos 2x upon x, that we have found equals to by formula p to infinity fp dp by using property number 3 as in equation number 1 above. This comes out to be p to infinity fp is here that we have found here fp. So this is p upon p square plus 4 dp. So now again you found fx, and now apply the property 3, that is integral p to infinity fp, and this integration becomes ln p minus 1 by 2 ln p square plus 4 p to infinity. Now this is your, in order to solve ln, this is p upon under root p square plus 4. Why we are writing in this form? Because in this form, in the present form, when we will substitute infinity here and here, it will be infinity minus infinity, indeterminate form. So we need to write the given ln p, this term and this in this form, so that we do not get indeterminate form. Now solving this, you can solve this further to get 1 upon 4 upon p square p to infinity. Now you can easily solve this one. So when you put infinity, it is ln 1, that is a 0, and then is ln 1 upon under root 1 plus 4 upon p square, and that is minus ln, this is your p under root p square plus 4. So we got the Laplace of 1 minus cos 2x upon x is equals to ln under root p square plus 4. We adjust the minus inside, and this one ln p square plus 4 upon p. So this is how we usually solve these type of questions regarding your related to your property number 3. Now we come to some of the very special questions that are related with this property number 2. So example 2, find the Laplace transform of gx equals to sin x. This is simple, as we did earlier, the question example number 1. The main point of this question is, hence, the important thing, hence show that 0 to infinity sin x upon x. Remember that integration sin x upon x by the known analytical method is not solvable. Integration is not possible by known analytical methods or method that we know. So Laplace help us to find the integration. So we will see how it works to find the integration, such type of integrations. So our first purpose is to find the Laplace of sin x upon x. So again you can see this is of the form fx upon x. So I am not writing again this form fx upon x, I am now doing it directly. This is now I have to find first. So since I am writing it directly, since I have told you this is basically two-step strategy. First step is to find the Laplace of fx, that is sin x here, and this is your 1 upon p square plus 1 in this case. Second step is to use the property whatever is going to be used in the question. So here it is property number 3, fx divided by x. So Laplace of sin x upon x is p to infinity fp dp. This is, so this is sin x upon x, property number 3. So solving this, it will be tan inverse p to infinity, and this is tan inverse infinity minus tan inverse p. So we got Laplace of sin x upon x is equals to pi by 2 minus tan inverse p. So this is my equation number 1, because I have to now prove the second part. So first part is done, that he was asking Laplace of sin x upon x is pi by 2 minus tan inverse p. Now the question, the other part is that you have to find this thing, that integration 0 to infinity sin x upon x dx is pi by 2. This is what now I have to find. Integration 0 to infinity sin x upon dx is equals to pi by 2. This is what I have to find now. So if you can see in these type of questions, they are related to the definition of Laplace. Okay, so what we have done here, we have found the Laplace of sin x by x using property 3, and we got this result. Now in the question, he is asking you the integration of this function sin x upon x from 0 to infinity. So how it will be done? Again, since by the definition of Laplace transform, if I simply write the definition of Laplace transform, it is 0 to infinity e raised to power minus px fx, and fx here is sin x upon x dx. This is what I got, the Laplace of sin x upon x, if I use the definition. So from 1 and 2, what we can say, from 1 and 2, we can say that this integral is equals to this value, because this is by definition and this is what we have got from property 3. Why we are doing this? Because we need this result. So from 1 and 2, I can write 0 to infinity e raised to power minus px sin x upon x dx is equals to your pi by 2 minus tan inverse p. Here is equation number 1, you can see here, tan inverse p. Now just you can see here, that I have got this form combining 1 and 2. What has been asked to me in the question is only sin x upon x. So how I can get the form sin x upon x only here? I can do it by putting p equals to 0 in this whole equation. Okay, so what I am going to do now, in order to get the desired integral value that he is asking, put p equals to 0 both sides. What we will get? 0 to infinity sin x upon x dx is equals to pi by 2 minus tan inverse 0. E raised to power naught is 1. So this gives you the result that is asked in this question, that is sin x upon x dx is equals to pi by 2. So done. So this is how we solve such type of problems of integrals which are given from 0 to infinity, because Laplace ranges from 0 to infinity. So here we use the properties and also finally the definitions to get these type of results. Let us do one more question of this type, which involves the use of property 3 and also the definition of Laplace transform. Show that 0 to infinity e raised to power minus x cos 3x minus cos 2x upon x dx is equals to half ln 1 by 2. See, we have to show, now he is not giving you first to find the Laplace. We have to determine ourselves that which Laplace we need to find first. So this question is something like 0 to infinity e raised to power minus x gx is equals to half ln 1 by 2, where gx is equals to cos 3x minus cos 2x upon x. I could have also taken e raised to minus x itself with this also, but it is better that I leave e raised to minus x separate, because then it will be simply putting p equals to 1. Otherwise we can also include this whole function as gx. We can include this whole function gx, and while comparing with the definition of Laplace we put p equals to 0. But since it is given in the form e raised to minus x, so let it be separated, as we can compare it directly with e raised to minus px, p equals to 1. So where gx is this one. So first I need to find the Laplace of this gx. Only then I will be able to find this integral using the definition. So let me first start with your Laplace of gx, because we have to first find the Laplace of gx, and this Laplace of gx, again you can see it is of the form fx upon x, property number 3, fx divided by x. So I need first the Laplace of your fx, that is here cos 3x and cos 2x. So I need Laplace of this first. Now since Laplace of cos 3x minus Laplace of cos 2x is p upon p square plus 9, writing it directly, p upon p square plus 4. So Laplace of cos 3x minus cos 2x by x, fx upon x, that is what we need here. This is what is p to infinity fp. This is my fp. The Laplace of cos 3x minus cos 2x is p square plus 9 minus p upon p square plus 4 dp. This is. So now solving this integral, this gives me 1 by 2 ln p square plus 9 minus 1 by 2 ln p square plus 4. This is p to infinity. Again writing it in the form p square plus 9 upon p square plus 4, so that I can avoid this infinity minus infinity form, undeterminate form, infinity minus infinity. So I am writing it in this form, and then I can solve this. I can solve this to get, putting infinity I will get ln 1, and this is ln p square plus 9 p square plus 4. This I got by putting infinity. You take p square common up and down, and then you will get this one. So this is 1 by 2 ln p square plus 4 upon p square plus 9, adjusting this minus here. So this is what I got, the Laplace of cos 3x minus cos 2x upon x. So this is equation number 1. Now, I has been asked in the question this thing 0 to infinity e raised to power minus x cos 3x minus cos 2x upon x dx is equals to 1 by 2 ln 1 by 2. This is what I have to prove or show. So now I got the Laplace of cos 3x minus cos 2x by x. By definition, Laplace of cos 3x minus cos 2x upon x is equals to 0 to infinity e raised to power minus px cos 3x minus cos 2x by x dx. Now you can see I can get this form by putting p equals to 1 here. Okay, so that is why we now use the definition. Now from 1 and 2, I got this 0 to infinity e raised to power minus px cos 3x minus cos 2x upon x dx is equals to, here it was, yes, 1 by 2 ln p square plus 4 p square plus 9. Now to get the desired result, that is this one, I need p equals to 1 here, only then I will get the desired result. So put p equals to 1. Now see, in case if I have extended this question, since I have taken fx only this one, see, if I have taken fx as this full function, then I have to do one more step, that I have to take the Laplace of e raised to power minus x dot this one, and that here p will be replaced by p plus 1 ka whole square, and here p plus 1 ka whole square, here and here. And then when I will compare it with the definition, then in that case I need to just put p equals to 0, because e raised to power minus x will already be there in the question. So I will not be there putting p equals to 1. In that case, if I am using if I am taking exponential function itself in the in fx, then I need not to put p equals to 1. So in this case, p equals to 1, I got 0 equals to infinity e minus x cos 3x minus cos 2x upon x is equals to 5 by 10 ln, sorry, this is, let me write it properly, this is ln 5 by 10, and that is what he was asking. It is half ln 1 by 2. So this is our required result. So this is our required result that he was asking for this question. So again, this is how we can use the property 3 and the definition to solve such type of questions. Now after this one, we have another property number 3. So, and another property 5. So 2 more properties are there. So we will be doing it in the next lecture. So we have 2 properties left, and after that we will be starting the inverse of Laplace transform. Till then, thank you. Thanks a lot.